All right, guys, so what we're doing today is we're going over the review sheet. Get y'all ready for your test next week. So this is the last test of the semester. Now, two things. One, the AMI is on the review sheet. So the certain problems, y'all wrote them down yesterday. If you didn't, the ones that didn't get a review sheet yesterday, I did write that at the top. So those are your AMI problems that you're going to work on this here. Also, I did post 2 videos already, so I posted them this morning, part 1, part 2, which goes through the entire review sheet. So the entire review sheet video is already posted. It's in 2 parts instead of 1, but it is all there. So hopefully get that there. So we'll look at this here. So we're going to work through these problems. Now for the first 3, 1, 2, and 3, we want to state the degree and leading coefficient. Degree, it would be negative 27. Because degree is the biggest exponent attached to a variable, which is 8. Leading coefficient is the number in front of that variable. And that's it. Now 1 through 3 and yes. And 8 through 10 determine if the following function is a polynomial. Those are going to be combined on the test. So the instructions are probably going to say something along the lines, determine if the following is a polynomial function. If it is, state degree. Essentially, if it is, you state the degree, leading coefficient. And I can't remember off the top of my head if it is, write it in standard form or not, but you just put essentially those two are together. If it's a polynomial, we say degree, leading coefficient. We do all that. If not, it's just no. Questions on 1, 2, or 3? Questions on 4 through 6. I would say 4 through 7, but 7's AMI. Yes, we can do one of them. Which ones do y'all want to do or look at? 5. Now, when evaluating a function for a given value, so again, that's a colon, not a colon, it's a semicolon there in the middle. All we're doing is we're taking negative 7 and plugging it in for x. So we have negative 7 cubed plus 3 times negative 7 squared plus 5 times negative 7 plus 1 grab the calculator. If I'm on the right page. Negative 7 cubed plus 3 times negative 7 squared plus 5 times negative 7 plus 1. We can type the whole thing into the calculator, replacing x with negative 7, and we get 456. So the answer is 456. That's all we have to do on 4, 5, 6, and 7. So we just plug that value in for x and see what it equals. Yeah. And the AMI is 1 from each section. Yeah. And the video does have all of them. Because if Friday wasn't an AMI day, I would have gone through the whole review sheet, but we just don't have time. Yep. 6 or 8, 9, 10. So determine if the following is a polynomial function. Now there is a whole list. I do have all these in the video. But if we look at number 8, so 8, yeah, might as well just say no, because we can't have a negative exponent. We also cannot have a fraction in an exponent attached to a variable. So here, for these here, yes. So 9 is yes, that is a polynomial function. Because on the test, it's going to ask for more. Because it's to determine if it's a following is a polynomial function. If it is, state the degree, leading coefficient. And I don't think it's going to ask for type, or if it does ask for standard form, you just write in standard form. So essentially 1 through 3, this is in standard form. I can't remember if it does or not, but essentially 1 through 3 and 8 through 10 are just combined. But if it's not, like 8 and 10, it's just no, it's not a polynomial function, because we only have to list it out, all the other pieces, if it is. Questions on 1 through 10? We feel good about 1 through 10. All right, number 11. So unfortunately we can't, because it doesn't like variables. It has to have a value for them. But 11 through 19, we're just simplifying the expression. So we're adding. Is there anything in front of this first set of parentheses? No, so we just drop it. 3x squared plus 4x minus 1. Since we're adding, not subtracting, we can really also drop the second set of parentheses. Normally, we don't put plus negative 2x squared. We just say minus 2x squared. Either is fine, because if we want to leave it as plus negative 2, or just say minus 2x squared, it's the same thing. And then we combine like terms. 3x squared minus 2x squared. 3 minus 2 is 1x squared, or just x squared. 4x minus 3x is plus x. And lastly, negative 1 plus 2, then plus 1. So x squared plus x plus 1. So we deal with the parentheses, combine like terms. That's it. Yep, because the 12 is going to be the same thing. We drop the parentheses and combine like terms. We ready to move on to 13? Now 13 is different. It is subtraction. Now the first set of parentheses still doesn't have anything in front of it. So it's still 7x to the fourth minus 9x cubed minus 4x squared plus 5x plus 6. And since we're subtracting, we have that negative in front of the second set of parentheses. We have to take that negative and distribute it through. So our 2x to the fourth becomes negative 2x to the fourth. Our positive 3x cubed becomes negative 3x cubed. Our negative x squared becomes plus x squared. Positive x becomes negative x. And negative 4 becomes positive 4. Now, at any point on the test, for some reason, you're not sure what the number is, ask. I will always clarify that. Because, again, you're not taking this test to be able to determine if you can read my handwriting or not. So if something's not clear, ask. I will clarify. Now, at this point here, it's the same as what we just did on the last one. At this spot, combine like terms. 7x to the fourth minus 2x to the fourth. 7 minus 2 is 5x to the fourth. Negative 9x cubed minus 3x cubed. Negative 9 minus 3. Negative 12x cubed. Negative 4x squared plus x squared. Negative 4 plus 1 is going to be negative 3x squared. 5x minus x is going to be plus 4x. And lastly, 6 plus 4 is plus 10. So really on these here, once we distributed that negative through, it was almost the exact same thing as addition. Can't type the whole thing in, but you can do the coefficients, the numbers in front, add, subtract, those there. Questions on these here? Yeah, 14 is going to be the same thing as that there. let's look at 15. 15 and 16. So 15 we're now multiplying. So we just need to distribute. We need to multiply through. 6x cubed times 2x squared. Well, our 6 times 2 is 12. X cubed times x squared, we add the exponents. When we multiply like bases, we add the exponents. So 3 plus 2 is 5, giving us 12x to the fifth. Now 6x cubed times negative 27x squared. Well, 6 times negative 27 is negative 162. And our x cubed times x is going to be x to the fourth. And lastly, 6x cubed times 4. 6 times 4 is going to be plus 4. X to the third. Since we don't have any like terms, we're done. Questions on 15? Not too bad. We're ready to look at 16. 16 is very similar to 15, but since we have two terms in front instead of one, we got to do this distributive property twice. And the first one we're going to multiply through is 2x. 2x times 2x squared, 2 times 2 is 4. X times x squared is going to be x cubed. 2x times 5x, our 2 times 5 is going to be positive 10. X times x is x squared. And 2x times 8, 2 times 8 is going to be plus 16. And we still have our x. Now we're going to do the exact same thing with our 4. 4 times 2x squared is going to be plus 8x squared. 4 times 5x, 4 times 5 is going to be plus 20x. And 4 times 8 is going to be plus 32. Now this one here, we do have like terms, so we do need to combine. Now 4x cubed is not going to have any like terms. Now 10x squared plus 8x squared is going to be plus 18x squared. 16x plus 20x is going to be plus 36x. And our constant term, our 32, doesn't have any like terms. So we have 4x cubed plus 18x squared plus 36x plus 32. And that's it. Questions on 16. Now 17, the one you're doing for the AMI, is the exact same thing. But instead of just multiplying by two terms, we're multiplying it through by 3. So you essentially do the same thing, you just do it one more time. 18 and 19, luckily enough, aren't on the test. No. And it's not because they're any more difficult than what we just did here. It's just that we multiply these two first, combine like terms. Then take that product and multiply by that. It's not that it's hard, it's not that it's difficult, it's just time consuming. So I'm not going to put it on there. I'd rather you guys work on the other parts than just this here. Because if you can do 15, 16, 17, y'all can do 18, 19. 20 through 24. Divide the two polynomials by synthetic or long division. You get a choice. And I have a feeling, especially with ones like this here, I have a feeling you're going to go synthetic division over long division. Yes? So with synthetic division, we set it up. We have our cubby and our bar. The first thing we need to do is find the number that goes into the cubby. So we take the x minus 5, set it equal to 0, and solve. So we add 5 to both sides, telling us that x is equal to 5. 5 goes in the cubby. Now we're going to put the numbers across the top, and those come from the coefficients of what's being divided. X cubed minus 10x squared plus 20x plus 26. Number in front of x cubed is 1. Then x squared is negative 10. X is 20. Constant is 26. If one of those is missing, we fill it in as 0. Or another way to remember is the number of numbers that we're going to have up there is one more than the degree. So since the degree is 3, we should have 4. 1, negative 10, 20, 26. We do have 4. So they're all there. Degree is the biggest exponent attached to a variable. 3, so we need 4 numbers. We good with how we set this up? All right, let's go through the process. So the first thing we do is multiply. 5 times 1 is 5. Negative 10 plus 5 is negative 5. 5 times negative 5 is negative 25. 20 plus negative 25, negative 5. 5 times negative 5 is negative 25. And lastly, 26 plus negative 25 is 1. Now we do need to fill the variables back in. The number in the box, the last number below the line, we do put in the box because it is the remainder. The number next to it's our term without x. The one next to it's term with x, and then term with x squared, telling us that we have x squared minus 5x minus 5 plus 1 over our remainder of what we're divided by, so 1 over x minus 5. And that's it. So out of the 4 division problems on the test, 3 of them you are able to do synthetic division, just like this here. The 4th you can do by synthetic or long division, but we have to set it up a little differently. But questions on 20 or 21? All right. '24. Actually, I'll give you all a choice. Do y'all want to do this by synthetic or long division? Y'all want to do this by synthetic? Okay. Now, synthetic's a little bit different. There's only one of these that requires synthetic division on the test. And that's the bonus. And it's the reason that this is bonus, especially on the test, is because what we're dividing this by, the x squared minus x plus 3, is not just 2 terms. Now, the numbers going across here, we can go on and fill in, because we have 3 for x to the 4th, negative 1 for x cubed, 8 for x squared, 5 for x, and 3. Since we do have a degree, let's see. It's supposed to be positive. Thank you. Yeah. Because yours has that written in as plus instead of minus. Yeah, I meant to change it on the notes or on the slides. I just haven't. Okay. Now, the first number goes all the way down past the second line. Second number goes down 1. Because since what we're dividing this by has 3 terms, those first 2 numbers come down. Now, to find the numbers that go in the cubby, well, we need to get x squared by itself. So the first thing we can do is add x, telling us x squared plus 3 is equal to x minus 3, telling us x squared is equal to x minus 3. Questions on this so far? We good with this here? Yes. Now we put the numbers in here. Well, negative 3 is going to go closest to the L, and the number in front of x is going to go in front of it, which is 1. And now we multiply just like we did before. All the multiplications with the 1 are going to go above the second line. So we're going to have 1 times 3, which is 3. All the multiplications of our second number, the negative 3, are going to go above the first line. So we'll have negative 3 times 3, which is negative 9. Now at this point here, we add straight down. 1 plus 3 is 4. 8 plus negative 9 is negative 1. Now we do the multiplication again. So we're going to say 1 times 4 this time, which is 4. And then we have negative 3 times 4, which is negative 12. Again, we're going to add straight down, so negative 1 plus 4 is 3. 5 plus negative 12 would be negative 7. And we do this again. 1 times our 3 down here would give us 3. Negative 3 times 3 would give us negative 9. You're good? I think just subtracted. Yeah. And lastly, we add negative 7 plus 3 is 4. 3 minus 9, 3 plus negative 9 is negative 6. Well, we've run out of numbers on the top. So all that means is we take this last one and bring it down so we're all under this last line. Now, all the ones before we boxed that last number. And the main reason is we're dividing by 2 terms. But here we're dividing by 3. So we're not going to box the last number. We're going to box the last 2. Because it's always 1 less than what we're dividing by. So when we have 2 terms that we're dividing this by, we box 1. When we have 3, we box 2. If we were dividing by 4, we would box 3. Now we need to go back and put the variables in. Now even with the remainder, with this here, first the number of the remainder is our term without x, the next one's the term with x. And that's part of the remainder. Oh yeah, and that should be, I was looking, I'm like, that doesn't look right. Negative 7 plus 3 is not 4. It is negative 4. Okay. Questions on that there, why I added that negative? Good. First number outside the box, the 3 is our term without x. 4 is our term with x. And our 3 is our term with x squared. So what we're left with is 3x squared plus 4x plus 3 plus our negative 4x minus 6, which is being divided by our x squared minus x plus 3. Questions on this here? So again, in the part 1, part 2 video, I do have long division, synthetic division with both of these. So if you want to go back and see it, I should have both of those listed. Okay. Questions on these so far before we look at 26. 25 and 26, find all the rational zeros, plus or minus p over q. So 25 and 26, we just have to find the rational zeros. We're not solving for anything. We're just finding all the plus or minus p over q. P is the factors of the constant term, our term without x. Q is the factors of the leading coefficient, the number in front of the variable with the biggest exponent. So our P is 15. So the factors of 15, we have 1 and 15, 3 and 5. Those are the only factors of 15. Q, on the other hand, we have 1 and 12, 2 and lastly 3 and 4. So we have 1 and 12, 2, 6, 3, 4. We have several. Now there's different ways we can do this. We can divide every p by all of the q's first, or do q's divided by p. Really what we're going to do, and what I do, is I just start with 1. Q's value of 1, and do 1 divided by 1, which is 1. Then I go to 3 divided by 1, plus or minus 3. Then we do 5 divided by 1, plus or minus 5. And lastly, 15 divided by 1, plus or minus 15. I think it's just nice to start there. And then I switch q from being 1 to being 2 and start over. We'll have 1 divided by 2, 1 over 2, which is plus or minus 1/2. Then we move to 3. 3 divided by 2 is plus or minus 3/2. Move on to 5. 5 divided by 2, plus or minus 5/2. And then we have 15 divided by 2, 15 over 2, plus or minus 15/2. Questions on this here before we move on to 3? Are you ready for 3? Now, we're going to do 1 over 3, 1 divided by 3, which is 1/3. 3 divided by 3 is 1. It simplifies, yes? If you put 3 over 3 on the test, plus or minus 3 over 3 on the test, I'm not going to mark it wrong. Because it's not wrong, it is correct, it's just not necessary. Because 3 over 3 is 1, we're just writing a repeat. We don't have to write any of the repeat terms. So we can just move on to 5 over 3. And then we have 15 over 3, and 15 over 3 is 5. We don't have to list it twice. And I'm going to move on to 4. So we have 1 over 4. So we have plus or minus 1/4. And 3 over 4. 5 over 4. And lastly, 15 over 4. Will be our last one with that. And then we do this again with 6. We can start off with 1 over 6. Then we move on to 3 over 6. But 3 over 6 is 1/2. So we don't have to list it. 5 over 6 doesn't reduce. And then 15 over 6 is going to reduce to 5/2, which we do have. And again, the calculator can do these reductions for us if you're not sure. And lastly, we have 12. So we'll start with 1 over 12, so plus or minus 1/12. 3 over 12 would reduce to 1/4, which we have. Unfortunately, 5 over 12 does not reduce, so we have plus or minus 5/12. And then 15 over 12 does reduce to 5/4, which we do have. So there's our answer. Again, it doesn't have to be in that exact order. I just need all of those listed. And especially on your homework, if you get that back and I have put check marks, it's just I'm checking off that those numbers are there, that they are all. So it's just me keeping track of them. Questions on our rational zeros, P over Q. Luckily, that's all you have to do with that. You don't have to solve for these here. You're just finding plus or minus P over Q. We go with 25, 26. 27 through 28. Use Descartes' rule of signs to find the possible number of positive, negative, and complex zero combinations that we have. We're going to look at 28 first. Or we're going to look at 28. Now, to find the number of positive zeros, we're going to come here and count the number of sign changes from one term to the next. Our first set is going to go from positive to negative, so that is 1. Then we go from negative to positive, which is 2. Positive to negative gives us 3. Negative to negative does not count. Negative to positive gives us 4. And positive to negative gives us 5. So the number of positives, the most that we could have is 5, or an even number less than it. So if we subtract 2 from 5, we get 3. We can subtract 2 again, we get 1. If we subtract 2 again, we go negative. It can be 0, just can't be negative. Questions on how we found our possible positives? Negatives, we need to count the number of sign changes for g of negative x, or f of negative x. We're just replacing x with negative x. Now, the first time we did that, we had to rewrite 6 times negative x to the 7th all the way down. But we did realize if we look at the exponent, and the exponent attached to that variable is odd, we change the sign. If it's even, it stays the same. If the exponent's even, it stays the same. If the exponent's odd, we change the sign. So 6x to the 7th. 7 is odd, so we change the sign from positive to negative 6x to the 7th. Our next exponent is 5. Since that again is odd, we change the sign from negative to positive 5x to the 5th. Our next exponent is 4. 4 is even, so the sign stays the same. So it's going to stay positive 27 x to the 4th. Next exponent is 3. Since that's odd, the sign changes to 30x cubed. Our next exponent is squared. So since that's even, it stays negative 20x squared. What do we do with 5x? Change it, because what's the exponent? Technically 1, we don't write it. 1's odd, so we're going to change it from positive 5x to negative 5x. And our 6 stays negative 6, because it has no variable. There's nothing causing it to change. Count the sign changes. We're going from negative to positive, which is 1. Positive to positive, positive to positive. Positive negative gives us 2. Negative to negative, negative to negative. So the number of sign changes for negative is 2, or an even number less than it, which would be 0. Now, I always start with the maximum number of each, 5 positive, 2 negative. Now, what's the degree for this here? 7. So how many solutions should we have? 7. If I have 5 positive and 2 negative, do I have all 7? Yes. So the number of complex that we're going to have is 0, because the number of complex is always what's left over. Because our other combination with 5 positives is 5 positives and 0 negatives. Well, if we have 5 positives and 0 negatives, that gives us 5 solutions. We need 7. So since 2 are missing, they have to be complex. Now we have every combination with 5 positives, so we can move on to 3 positives and 2 negatives. Well, 3 positives, 2 negatives give us a total of 5. Has to be 7, so we're missing 2. We can also have 3 positives and 0 negatives. Total of 3 solutions. How many are we missing? 4. 4 complex. We only have 2 left because we did all the ones with 3 positives. Now we have 1 positive and 2 negatives. Total of 3. So how many are we missing? 4. And lastly, 1 positive, 0 negative, and 6 complex. Just as a hint, complex is always going to be 0 or an even number. Always come in pairs. Either we don't have any, or it's a pair of 2, 4, 6, 8. Going up. Questions on this here? We feel good with Descartes' rule of signs. And again, with Descartes' rule of signs, we're not having to solve. We're just listing this out, this table. All right, we ready for the last section? Number 30, because I gave you all 29. So looking at this here, how many solutions should we have? 4, because the degree is 4. Okay. First thing I would do is put it in the calculator. Let the calculator graph this for us. So, page. So we're looking at x to the 4th minus 6x to the 3rd plus 7x squared plus 6x minus 8. Now, every problem on the test will give you enough solutions to get it to a quadratic. So we have 4 solutions we need to find. This one should give us at least 2. If it gives us 3, that's even better. If it gives us all 4, that's the best outcome. And if we graph it, we do see that it crosses 4 times. Yes. So negative 1, 1, 2, 4. We're looking for what value of x makes the y value 0. So yes. So we could write it as plus or minus 1, 2, 4, or x is equal to negative 1, 1, 2, 4. But it gave us all 4 solutions. We needed 4. The calculator gave us 4. We are done. Because if it gives us all the solutions, we don't have to find the rest. Yeah.
It doesn't matter what variables are.
No, and I'm not going to be a nitpick about that because it really should be f of m, not f of x. I just realized that. But no, I'm not going to be a stickler about the fact that you're solving it. It gives it in terms of m, but you put it in terms of x. You did the process. That's just copy error. Questions on 30? Do we want to look at 31, 32, 33, or 34? We feel good with these here. Because if it doesn't give us all of them, we have to get it down to a quadratic and use quadratic formula, completing the square. And not so much completing the square, you can. Yes. Or those there, or quadratic formula. Here, 31, the first place I'd start with 31 is plugging it in. X to the 3rd. Okay, well, let's just clear all that out. X to the 3rd minus 11x squared plus 41x minus 51. Because we're looking for at least one solution. Because if I get one, it gets it down to a quadratic we can solve. And incidentally, it only gave us one. And that's 3. Now, we could have a repeated solution, yes. And for that to occur, that 3 needs to show up 2 more times. Because if it crosses, it shows up an odd number of times. Now, if it doesn't give us all the solutions out the gate or immediately, we need to take each solution that is given to us, use synthetic division to decrease the degree. So one solution will decrease it from a degree 3, x cubed to x squared. So 3 times 1 is 3. Negative 11 plus 3 is negative 8. 3 times negative 8, negative 24. 41 plus negative 24 is 17. 3 times 17 is 51, which does give us a remainder of 0. Now, we don't have another solution, and 3 is not going to work, again, unfortunately, because it would give us a remainder of 2. So what we have to do at this point is plug our variables back in. Telling us that we have x squared minus 8x plus 17 is equal to 0. Now for this one here, because we do have a middle term, we have that negative 8x, we're going to need to use the quadratic formula. If the negative 8x wasn't there, it's just x squared plus 17, we can use square root method, subtract the 17, take the square root, we're done. Here we're going to have to plug it into the quadratic formula. Negative v, so we have negative 8, plus or minus the square root of negative 8 squared minus 4 times 1 times c all over 2 times a. Now luckily for us, negative 8 is just 8. 2 times 1 on bottom is 2. I would take everything inside that radical and plug it into the calculator before we do the radical. So we have negative 8 squared minus 4 times 1 times 17 is negative 4. Now before this year, we couldn't take the square root of negative 4, but we can now, because the negative is going to come out as I. Now the square root of 4 is 2. So the square root of negative 4 would be 2i. So do we need to simplify from here? So the only reason I would make you simplify from here is if both terms on top and the one on bottom have a common number. Well, they all are divisible by 2, yes? And this is actually going to simplify nicely. 8 divided by 2 is 4 plus or minus I. Our 2i divided by 2 is I. So we have 4 plus or minus I and 3. That's it. Questions on this here? So the AMI is that set number of problems from the review sheet. I did post it in Google Classroom what those problems are, just in case you forget. Yes. I didn't mark it off. Yeah. Yes. Yes. Also, guys, so next week, I think most or all your teachers. Yeah.